When drawing Newman projections, you are asked to look at the compound from a certain angle where the two carbons are stacked on top of each other. So you're looking at it this way, and what you see is only this. And this is how you would draw it. Let's look at a 3D example. So when you usually draw an organic compound, this is how it looks like in 3D. This is the organic compound you drew. In 3D, it looks like so. However, when you want to draw it in a Newman projection conformation, you want to look at it where the two carbons are stacked on top of each other like so. So you can't see the back carbon, however, you can see the groups that are attached to it. So it could be like this, or you can also face it from the other way like so. So when you're asked to draw a Newman projection, you're going to be told what carbon you want to look at. So over here, it tells us that we want to look at this carbon. So this carbon is in the front, and this one's in the back. So we won't see this carbon. However, we will see the compounds attached to it. And we're going to draw the Newman conformation. If an element or a compound is on a wedge, then we draw it on the right side. If it's on a dash, we draw it on the left side. And if it's within the plane, then we draw it within the plane. This is how it's going to look like. So we first start off by drawing a circle. And depending on how we're looking at the compound, we're either going to do this for the front carbon or this. And that depends on the element that's within the plane. So over here, the element that's within the plane is facing upwards. So we will draw the conformation like so. As for the back carbon, we draw the lines outside of the circle and they don't go in, and that's how we represent that it's in the back. So over here, this is the front carbon, and here is the back carbon. We see that the chlorine is drawn on a wedge, so that is going to be on the right side. The hydrogen is drawn on a dash, so it'll be on the left side. And the methyl group is within the plane, facing upwards, so it'll be right here. As for the back carbon, the methyl group is facing downwards within the plane, so it'll be here. This hydrogen is on a dash, so it'll be on the left side. This hydrogen is on a wedge, so it'll be on the right side. And this is what the conformation is going to look like when looking at the compound from this angle. Alright, now let's say we want to look at it this way. So if we're looking at the compound this way with this carbon being in the front, as you can see, the element that's within the plane, the methyl group, is facing downwards, which is why over here we have the structure drawn like so. So it's kind of the same thing. Here's the front carbon, here's the back carbon. Again, the methyl group is within the plane facing downwards. This hydrogen is on a wedge, so it's going to be drawn on the right side. This hydrogen is on a dash, so it'll be drawn on the left side. As for the back carbon, the chlorine is on a wedge, so it'll be on the right side. The methyl group is facing up within the plane. And the hydrogen is on a dash, so it'll be on the left side. So these are the two conformations of the same compound looking at it from different angles. Now you're also going to be asked to rotate the carbons. You'll either be asked to rotate the back carbon, the front carbon, clockwise, counterclockwise, and however many degrees the professor tells you. So let's go back to the first confirmation where this carbon was the front carbon. And we are asked to rotate the back carbon 120 degrees clockwise. So this way. The backbone structure is going to stay the same because we have rotated it 120 degrees. If you were asked to rotate it 60 degrees, then it won't be the case, and we'll see that later. So since we're asked to rotate only the back carbon 120 degrees clockwise, the front carbon is going to stay the same. So we just copy those over. So rotating the carbon 120 degrees is the easiest because the compounds just move one over. So this methyl group is going to take place of this hydrogen, and this hydrogen is going to take this hydrogen's place, and this hydrogen is going to take place of the methyl group. So this hydrogen is going to be within the plane facing down. The CH3 group is going to be on the left side. And this hydrogen is going to take place of the other hydrogen. And now we want to rotate the back carbon 120 degrees clockwise again. We're moving this way. And again, we keep the front carbon the same. So the methyl group is now going to take place over here on the right side. This hydrogen is going to move down, and this hydrogen is going to go to the left side. Now you're being asked to rotate the front carbon 60 degrees counterclockwise. We are going this way. So from here, we're keeping these compounds on the back carbon the same, and we are only rotating the front carbon. However, since we're rotating the carbon 60 degrees counterclockwise, this is not going to stay the same. It's going to be like so. So we did a half rotation counterclockwise. We didn't do a full rotation where it would still kind of look the same. So since we did a half rotation, this methyl group is still going to be here. This hydrogen is also going to still be here. Now since we're also again rotating 60 degrees counterclockwise, this is also not going to be like that. It's going to go back to this form since we only rotated it 60 degrees. And this H is going to be here. This chlorine is going to be here, and this methyl is going to be here. This is called the eclipse conformation, where in reality they're actually on top of each other. We draw them like that so we can see them, while this is called the staggered conformation. So in 3D, this is a staggered conformation, and this is what the eclipse conformation looks like.